Our next topic is statics. Although we came across some problems before, right, in the previous chapters about statics, but let us explain clearly what we mean by statics. Here we have particles acted upon by forces, but the particle is at rest. We did solve some question when I said a particle is in equilibrium. This is statics. So we are solving more cases of statics. Statics, we will have problems similar to the previous problems in other chapters where we have motion, but this time there is no motion. We have similar forces. We're going to resolve as usual, but the particle doesn't move. Therefore, we are not going to say in one direction we have equilibrium and in one direction we have motion, forces with motion against motion equal ma. Here A equals 0. This means forces right in the two directions. In the vertical direction forces are balanced. In the horizontal direction forces are balanced. Let us take an example. Now we have a particle, right? Or in actual fact, we can just say we have forces like this. A force of 6 Newton acting at 45 degrees. And a force of 2 Newton and a force of 2 Newton act at 60 degrees. And one force vertically down 4 Newton. Maybe this could represent the weight of the particle. And a force P making an angle theta, right? Now, we are given that these forces are in equilibrium, and we are asked to find the value of P and the angle theta. So what are we going to do is we are going to resolve horizontally and vertically. So let us say we resolve horizontally. Horizontally we have 6 cosine 45 to the right, and we have 2 cosine 60 plus P sine theta, and not cosine, because the angle theta is with the vertical. Therefore, the vertical cosine and the horizontal is sine. Right? This equation, we calculate the value of 6 cosine 45. Therefore, using calculator, and we calculate now, right, 6 cosine 45, it will be 4.246 3 minus 2 cosine 60 is 1. This is P sine theta. يبقى P sine theta equal 3.243. And then we are going to resolve vertically. So we have 6 sine 45 plus 2 sine 60 equal P cosine theta plus 4. 6 sine 45 is again 4.243 because sine 45 and cosine 45 are the same, plus 2 sine 60 is 1.732 equal P cosine theta plus 4. Therefore, the value of P cosine theta equal to, right, we add these together, we get 5, 7, 9, 5, minus 4. Therefore, we get P cosine theta equal 1.975. We have P sine theta and P cosine theta. In this type of problems, it is known whenever we have P sine theta and P cosine theta, the value of P will be the square root of the two values, 3.243 square plus 1.975 square. And we get the value of P. And tan theta is equal to, we divide what has sine over cosine. Sine is 3.243 divided by 1.975. From this we will get the angle theta, and therefore we know that now the value of P and the value of theta. Let us have another question. This one is from the book. It says, there is this example 1 in the book. It says that, right, 3 forces a particle, anyway, it has 3 forces acting on it. One force P, right, making 30 degrees, and one force 4 making 45 degrees, and one force Q vertically down. And we are asked to find P and Q. So in the previous question, we were asked to find a force and an angle. And we always get P sine and P cosine, then we get P square root and tan theta as division. But this time we have P and Q. Therefore we are going to get two equations, or we are going to get to solve equation. We've got the values of P and Q by equations. Now, if we resolve horizontally, we have P cosine 30 equal 4 cosine 45. From this, we get straight away the value of P. And the value of P straight away will be 3.27. And then we resolve vertically. P sine 30 plus 4 sine 45 equal Q. We know the value of P, we substitute the value of P, we will get the value of Q, and Q equal B 4.46. This problem is a very special problem because it is three forces in equilibrium, and three forces in equilibrium is a very special force. It can be done by resolving like what we did, and it was easy even by resolving. It can be done also by drawing the triangle of forces. Triangle of forces. How? We try to draw the three forces one after the other. For example, right, I can draw the force P, making 30 degrees first. Right, this is making 30 degrees. Then I'm going to draw the force Q vertically down. The force Q vertically down. Then I'm going to draw a force of 4, this force of 4, making 45 degrees with the horizontal, and we should close a triangle. Three forces in equilibrium must close a triangle. Why? Because when we add vectors together, the vector from the starting point to the finishing point is the resultant, and since the resultant is 0, means the starting point and the finishing point, they are to coincide. This is the triangle. This triangle we can solve it by sine rule, because we have this angle 45, we have this angle 60 degrees, and this angle is 75 degrees. This angle is 75 degrees. Therefore, we are going to write the sine rule. What is the sine rule? We are going to write P divided by sine 45 equal Q, right, over sine 75 degrees equal 4 over sine 60 degrees, from which we get the value of P is 4 sine 45 over sine 60, and we get the value of Q equal 4 sine 75 degrees over sine 60, and we get the values of P and Q. Also, there is a third way, also acceptable, is a new way, very interesting way. If I draw the forces P, 4, and Q, and Q. Now, this is P, this is Q, this is 4. What is this angle here? 120 degrees. What is this angle here? 90 plus 40 is 145. 9 plus 45 is 135 degrees. And what is this angle here? Right? Is 120 plus 135 right? We get this angle 75 degrees. Now, 120 plus 135 is 2, right? 255. This angle is 120, correct? Yes, 105. This angle is, right, 60 plus 45. This will be 105. This angle will be 105. Yes. Now, 20 plus this will be 255 from C60 is 105. The method is very simple. It say you divide each force over sine the angle facing it in the other side. And we say P over sine 135 equal, right, Q over sine 105 equal 4 over sine 120, which is the same as what we wrote there, except that we are now dividing by the supplement angle. P over sine 45. What is the supplement of 45? 180 minus 45? 135. Q over the supplement of 75, 105. 4 over supplement of 60 is 120. The easy thing is that you don't need to draw the triangle. Yani you can write the sine rule without drawing the triangle. Here I needed to draw the triangle. Anyway, it is good to learn how to draw the triangle. Yeah, but we have problem. This 3 forces in equilibrium can be done by resolving, can be done by drawing the triangle first, then the sine rule, or it can be drawn, it can be solved by the sine rule, but just from the angles between the forces, between the original diagram given, the angle between the forces. And we can write. This is, at one time we call it Lamy's rule. This is, it is famous by the name of Lamy rule, that we divide each force over sine the angle facing the other side. It is the same as the forces of a triangle, except that we don't need to draw the triangle. Anyway, the 3 methods are correct. Whatever method you do, it is correct. Now, we'll go to another example. Another example which is, right, diagram given some forces here. There is one line here making 31 force there, 8 Newton, making 30 degrees with the horizontal, and one force is vertical, 5 Newton, and one force is like this, 3 Newton, and one force is inclined right. what is wrong? Yes, now is correct. One force inclined now this way called P at an angle alpha there. Right? And now these forces is in equilibrium. And we need to find again the force and the angle. It means that we are going to get two equations, one P sine and P cosine. Now we consider this problem as if the problem of inclined plane, which means we are going to resolve right? We are going to resolve in this direction and in this direction. Right, we are going to resolve, yes, in this direction. This is our x direction and this is our y direction. Right, and this is our y direction. So remember that 5 is just like weight. The weight is resolved. Yibba here 5 cosine 30 and here is 5 sine 30. And the P is resolved, P cosine and P sine. This one here will be P cosine alpha and up there is P sine alpha. This means that P cosine alpha equal 8 plus 5 sine 30. If P cosine alpha equal 10.5. Then P sine alpha plus 3 equal 5 cosine 30. P sine alpha equal 5 cosine 30 is 4.33 minus 3 means 1.33. Right? The force is 2. Sorry, this force is 2, not 3. Therefore, the force is 2 here. Therefore, this will be 2.33. That force is 2 Newton. We have P sine alpha and P cosine alpha. So the value of P is the square root of 10.5 square plus 2.33 square. You will get the value of P equal 10.8. And you will have the value of tan alpha equal 2.33 divided by 10.5, from which you get the angle alpha is 12.5 degrees. So again, this is a statics, which means it is a balance of forces in two directions. But here we found that when we have the forces in the majority of the forces are in one direction and perpendicular, then we consider it like a problem of inclined plane and we resolve the weight. And by doing this, we find the problem is easier. Fine. Now, most these problems we have done did not include friction. Now we have a force, a static force also, but that includes friction. Now, right, before we have a problem which includes friction. We have here a problem to tell us one fact. What is it? Is that if I have a string and I hang on the string, I threaded the string on a ring. It is the same string, I threaded it in a ring. The tension in the two parts of the string is the same. When we have a particle attached to two rings, when the particle attached to two strings, then the tensions are different. When a particle is tightened up in one string, again the tensions as if the two sides are two different tensions. The only case we have that the tension is the same when it is mentioned that the ring is threaded on the string and a smooth ring threaded on a string. In that case, the tension is the same. We have this particle. A smooth bead Y is threaded. This is example 3. A smooth bead Y is threaded on a light, inextensible string. The ends of the string are attached to two fixed points X and Y on the same horizontal level. The bead is held in equilibrium by a horizontal force of magnitude 8 acting parallel to Zx. The bead Y is vertically below X and the angle XZY is 30. The diagram is like this. This is the line joining the 2 points X and Z. This is one string going like this. The string is going this way and that way. This is all one string, and this is the ring. Why the ring? Usually the ring should be in the middle because it is the same string and the same tension. But why the ring moved this way? Because of this external force of 8 Newton that made the bead move to the left. Without that force, then the string will be like this, and the tensions on both sides equal and the angles equal. But this time no, because we have an external force which have pushed the ring to the left. It is given what we know only now from the fact that it is the same string threaded, that the tension here is the same as the tension here. Now, the angle there is given to be 30 degrees. The angle there is given to be 30 degrees. Therefore, this angle there is 30 degrees. And the weight of the particle unknown. Right. He wanted the weight of the particle. Again, this is a problem of statics, which means we resolve horizontally and vertically. Horizontally, the forces are balanced, and vertically, the forces are balanced. Horizontally, we have T cosine 30 equal 8, from which we got the value of T is 8 over cosine 30. From which we got the value of T is 9.24. Then we resolve vertically. we got T plus T sine 30 equal W. يبقى T plus 0.5 T equal W. 1.5 T equal W. Therefore, we got the value of W equal to 13.9. That is the question. Now we will go into problems, right? We have to find problem first about friction. Yes. Now, yes. Now, all these problems we solved, there was no friction. Now we wanted to have problems including friction. We are going to take example 5 in the book. A mass of 8 kilograms resting on a rough horizontal plane. We took before, when we have a rough plane, we have a force called frictional force, and the limiting friction is mu r. Here in this topic we don't have motion, therefore the frictional force would be less than mu r if it doesn't say in the question that we have a limiting equilibrium. Once we have a limiting equilibrium, then F equal mu r. We have this question that a particle, a mass Now, the problem that we have a mass of 8 kilograms, right, rest on a rough horizontal plane. Therefore, its weight is 8g, and there's a normal reaction R. The body is pulled up by a horizontal force P, therefore there will be a friction F. It says in the question that the coefficient of friction mu is 0.5. Right? Find the magnitude of the maximum force P which act on the mass without causing it to move. Means the maximum P which will just start motion. Therefore we wanted P to just start motion. This means the friction is limiting. This means F equal mu R. The value of R equal 8g. The frictional force F equal mu R. Therefore, the frictional force equal 0.5 times 8g, which means 4g. Therefore, the force P equal 4g. because P equal F. But therefore the force P equal 4G, and therefore it is right 39. We know this would be 39.2 Newton. The same question, it is asked that the force was acting, making 60 degrees. The same force, right? Now, sorry. Now, the same problem, it is that the mass and the force acting is making 60 degrees. Therefore, we have the weight Ag, we have the normal reaction R, we have the frictional F. Now, the force, this force P will be component here P cosine 60, and component there P sine 60, P sine 60. Then R plus P sine 60 equal Ag. Then the value of R equal Ag minus P sine 60. Again, because he said that the force, right, needed is the force to just start motion, because it said that I need the force which is just to start motion. Even therefore F equal mu R. F equal to 0.5 times Ag minus P sine 60. P cosine 60 equal F, which means P equal cosine 60 is 0.5. That means P times 0.5 equal F, means P equal 2F. But therefore P equal 2 times 0.5 times the bracket, which is Ag minus P sine 60. But P equal Ag minus P sine 60 is root 3 over 2. So therefore we got the value of P bracket 1 plus root 3 over 2 equal Ag. We calculate the value of P. Right. And the value of P will be 42 Newton. Now, therefore, in these problems now, we included friction. Once it says that the body is about to move, then the frictional force equal mu R. If it doesn't say, even frictional force doesn't reach that value, mu R. Let us have one more question. A particle on inclined plane. Now, the question is this. A box of mass 10 kilogram, this is example 6 in the book. A box of mass 10 kilogram rest in limiting equilibrium. It says here, limiting equilibrium on a rough inclined plane at 20 degrees. Therefore, I have a plane inclined at 20 degrees. And this is the box there. The mass is 10, but the weight of the box is 10g. Of course, normal reaction. Always in problems, the first forces you put are the weight and the normal reaction. You put the weight and the normal reaction, the weight vertical and the normal reaction perpendicular to the plane. Then you read the question carefully to know in which direction is mentioned in the question, that if it was motion, they will tell you which direction is motion, then friction the opposite direction. Here we say which direction the body is about to move. It says here, right, that the coefficient of friction, right, you say in the first question is that we need to get just the coefficient of friction because the body rests like this in limiting equilibrium. No other force. No other force, of course, the body tending to move down. If the body is tending to move down, even friction is up. Fine. Now we resolve the weight. The weight here is 10g, right, this one we know it, cosine 20, and this force is 10g sine 20. Then we know that R equal 10g cosine 20. And F equal 10g sine 20. We know that F equal mu R. Then mu is the ratio of F over R. Therefore, mu equal to 10g sine 20 over 10g cosine 20, and we get the answer. And the answer would be 0.36. So we got the coefficient of friction between the particle and the plane. Now the question say that this particle is pushed, it says in the question, a horizontal force of P is applied to the box. Given that the box is in equilibrium, find the maximum possible F. The maximum possible F means the maximum possible value to just to start motion. Right? Therefore now the problem is like this. This is a plane like this. This is the angle 20. This is the box. This is the weight of the particle 10g. And this is the normal R. The force is horizontal this way. So therefore we extend it this way. This is the force P, which we wanted to, the maximum force means the force just makes body about to move up if a friction is down. Therefore, we have the weight 10g cosine 20, and this is 10g sine 20. P is resolved, P cosine 20, and this way P sine 20. Then we have R equal P sine 20 plus 10G cosine 20. We have, since we need the maximum force, therefore the particle is just about to move, يبقى F equal mu R. يبقى F equal 2.36 times P sine 20 plus 10G cosine 20. Now, forces along the plane, P cosine 20 equal F plus 10G sine 20. يبقى P cosine 20 equal F is 0.36 open bracket P sine 20 plus 10G cosine 20 plus 10G sine 20. The only unknown in this problem is P. We solve it to get the value of P, and P will be 82 Newton. P is the only unknown in this equation. If it says in the question that we need the maximum force to hold the body at rest, means the maximum force to prevent the body from motion, means the force which will just make the body just move, and therefore we have limiting friction. And if we have limiting friction, this means F equal mu R. This is the end of this chapter, right? And you have to solve all the questions in the review exercise.